Welcome back. You're watching Centerline Designs. My name's Cole if you're new to the channel, and not in my house right now, and we're also not out in the shop. My daughter had to have some surgery that took us out of town for a little while, so while we're out of town, I thought I'd take this opportunity to put together a video compilation of a year's worth of Snowcat Building. We're right on the 1-year anniversary from when I started the build, and I've had some comments about not being able to see enough progress in videos, and it is a very delicate balance between showing enough progress but also showing enough detail, because I've also seen that people like to hear my train of thought and the way I think about building this Snowcat. So anyways, for those of you that like to see a lot of progress, or if you haven't seen this build series at all, I'll throw a link to the playlist down in the video description below, and I think we're 23 parts into it, so without further ado, enjoy. Well, hello there YouTube. The donor car is here. Just got home last night with the car that's going to provide the motor for the Snowcat. It's a 2000 Jetta wagon. It's got a 1.9 liter TDI diesel ALH. So we got 2211 by 8 turf tires. I've been debating going with a suspension or not. I think I'm basically going to go the Argo Muddock style turf tire, 4-bolt stub axles. And the chassis is going to have 4 axles that these stubs all receive into. And I think it's going to turn out fun. There's going to be one space sack here for the drive sprocket. That'll be a 12-inch diameter and raked up a bit at the back. Overall, numbers are the vehicle is approximately 11 to 12 feet long. And the cab is going to be about 5.5 feet by 5.5 feet approximately. It's going to be 3-door, 5-seater. I have the pumps on order, a tandem setup, variable displacement piston pumps. We have that 90 horse turbo diesel. I'm just looking at possibly going to a 2-stage motor for a high and low range. And then we'll be running a 3rd auxiliary gear pump on a magnetic clutch for all the plow controls. All right, we're gonna get started on part 2 today. I figured the best place to start was to get these axles built. We're doing a drop axle. The drop portion of the axle is all gonna be contained within the track, so that will leave us with nothing to get hung up on under the vehicle. We'll gain an extra 2 inches of ground clearance, and I figured the extra work was worth it. We're gonna cut the main section of 2-inch 250 wall aluminum square tubing. The drop sections are also 2-inch by 250 wall. We're gonna sleeve them with 1.5-inch 120 wall, which will make a perfect receiver for the spindles we're using, which is a standard 1,000-pound, 1,200-pound stub axle. You get at any trailer parts store, fairly inexpensive. The beauty is if anyone ever has problems, you don't need specialty parts. We can keep the price down and make any repairs easy. All right, we got some of the first cuts made, and wow, are they ever ugly. I mean, look at that. Horrible, horrible, horrible. It's time for a new blade on the old chop saw. Good thing I just ordered one. We got the deburring done. The one thing I forgot to get cut up were the 1.5-inch 120 wall sleeves. So I got all 8 of those cut up, and well, I guess it's to be expected. The tolerances on the material are give or take maybe 5 to 10 thou. So I actually had to search through my pile. Luckily I was able to use up a bunch of scraps I always keep because it always comes in handy. So I got those 6-inch pieces cut up, pushed in. Most of them I was able to put in with just a dead blow. There were a few though I had to go and press in. Well, that was fun. I haven't spent that much time setting up drilling and kind of getting into assembly mode in a while. It felt good, really did. Been away from fabricating for a bit, so getting into this feels pretty good. So we got all 8 spindles and sleeves drilled. I marked them all because I really didn't feel like spending the time to make it truly repeatable. So everyone's probably slightly different. Kind of a believer in spend time where you need to and don't where you don't. All right, well, we just finished doing some layout here and fixturing. Kind of mocked everything up here temporarily, put the hubs on, I've just been getting everything clamped down, measured, trued up. Made a few changes, pulled the receiver back in there. I wanted to run the flat bar down, capping off the actual axle tubing and tie it into the 1.5 inch. Then we'll do some stitches along each sides, bring a piece of flat bar to close up this onto here, sort of help everything transition. But it's looking pretty good. We got it all clamped in place, spaced. It's all nicely checked, hub face to hub face. 55 1/4. Happens to be a quarter over what I was thinking, but that's fine. It's just going to add into the overall clearance from the machine. I just need to make the other 4 the same. I'll be building this little aluminum fixture jig just to help the frame stay true and everything as we're welding and piecing it all together. I'm just checking things, spacing between the tires. Now is the time if I want to lengthen or shorten the vehicle at all. I have that opportunity. Got started at the front here. My plan is to come out a little bit, go 45, we'll go up, and then that'll kind of turn into the front of the machine where the windshield is and everything. Well, progress is coming along pretty good. It's really just been going together, no problems. Everything seems lined up and it's staying square and looking really good. Center tires aren't actually bolted on, so they look a little wobbly. But there it is. Chassis coming together. A couple more hours and it will, main chassis will all be together. I'll get the top rails on and all the verticals and the triangulation in there, which is gonna just make this unbelievably rigid. Figure this is a good place to take a pause and just kind of talk about what I've been doing here. So I did get the fronts and the backs all mocked up and welded in yesterday. And then I realized I had forgot to cut the 45s on the tops. And I was thinking about avoiding that and just putting other tubing on top to seal it off, but I really like the idea of kind of fully cutting all the joints and sealing everything off together, and then when I weld in the cross tubes, it really ties everything together a little bit better. So I went ahead, cut the tacks, went backwards for half an hour, which is, it's fine, happens. Didn't worry about it. I did have to shrink the overall length of the vehicle. By the time I got everything tacked in and took my final measurements, I was 1.5 inches over, because ultimately the 2 top rails came out a 24-foot length, 2-inch by 250 wall, and that was the last full length I had left. So that was really my determining factor. So I cut 1 inch out of the back and 1/2 inch out of the front at the same time, and I'm pretty happy with overall measurements.
Alright, well the audio on this clip didn't come through very good. Tiger Torch was just way too loud. What I'm trying to say here in the video is that I'm heating up this base material before I come along and fully weld in everything. I'm heating it up to the point so that it causes condensation on the aluminum, and if you kind of look at the sheen or the texture, it changes, and then I burn that condensation off to know where I'm getting it hot enough. And that seemed to put enough heat in that when I came along with the spool gun, it could put more time into actually welding. It eliminated most of the cold starts and really helped with the penetration of the weld. So I'm really happy I took the time to do that. It made all the difference, and I'm sure that'll help with longevity. So yeah, hope you enjoy. Got lots more to go, and keep watching.
All right, took a little break there, let the welder cool down, and I needed some lunch myself. So I have one side almost fully welded in, other than the bottom, which I need to take the frame off. But as you can see, that is just burning in beautifully. Preheating's helping a ton. Once we clean all the soot off and everything, it'll all look a lot cleaner. Some outside joints to do still, but it's going in nicely, and it's hard to see on camera, but by eye everything's looking nice and true, parallel, square, you name it. I got some wood blocks in there to keep it from squeezing together. I just wanted to get these insides welded and ground down, and then also have some cross sections. I'm not planning on welding too much in the center right now. All right, here's the second one. Here's the first. Let's see. We bored that to what I think is the exact same dimension. Oh, I love it. I love it. Look at that. That is flush. And I only got as far as making the actual steel wheel motor mounts yesterday. The video of it isn't going to be exactly as I wanted, as you maybe have seen. I was testing out a new mic with my camera, which wasn't picking it up, so I wound up losing a bunch of audio. But that's okay. I still have some of the footage. I mean, it's just fabricating stuff there. So this is the way it's going to sit. This whole assembly is going to move forward and back to allow for our track tension. That hub with the hub face will go on here. We're going to have the same tire as we have on the rest of the vehicle to keep things interchangeable as a drive tire. The grousers are going to drop in between the lugs. The spacing will work out perfectly. That this tire, due to the friction put on it through the tensioning and also the actual lugs itself, is going to grab those grousers and rotate the tracks. I'm pretty confident in it working well. There's a lot of friction that's going to be developed over the 180 degrees of this tire that's in contact with all of the grousers. So I think it's going to work out well. Today, the goal here is to finish working on the back frame. We need to put a vertical support in. We need to add on another piece, weld it all in, of 2-inch heavy wall. And then I'm going to put some flat bar in here and add on the angle supports that will also allow us to cinch and bolt everything down. So yeah, the rest of this episode's pretty much going to be cutting, fitting, doing some welding in here. I'm going to get all the pieces cut up
and not really bore you with that process. And once I have everything cut, I'll get the camera rolling in here, and you can kind of see all this come together. And then if I really feel ambitious, I might finish getting it all final welded in. That's my goal for today. Let's see if I can get it done.
All right, here we go, back to the fun stuff, working with aluminum. As always, got to get it wire brushed, get that oxide layer off, and then after that I like to come in with a rag with some acetone on it and wipe any of the oils and greases and kind of the wire brush dust off. Once I was done that, I got into setting it all up and put a little clamp on there for some tension and tap that upright into place. I took the weight with a jack to kind of help stabilize it, and then we really get into checking square here. Just keep checking, tap it, check again. It's I've learned over the years you want to be as square as you can and keep checking, because often when you check later on and it's not what you want, you get frustrated. After that, come in with the spool gun, try and tack all the corners. I really never utilized the spool gun too much in the past. I primarily TIG for a long time with aluminum, but doing something like this, you really got to get that spool gun. It would just take too long to get in there with the TIG and do it like that. The spool gun, it's a little bit cruder of a method, but it's a little faster at getting that heat into that base metal. And try not to put too much heat into any one area until you have everything held together as kind of one first. After I got that stub tacked on, I worked on getting the square piece of flat bar clamped into place, and then just as every other part, get a bunch of tacks on all around it, and then move on to the next piece. And once we do that, we move on to the next part. It's always best to put a component together with its pieces, tacking it first. If you go and put a part in and weld that joint and then move on to the next, things will start warping and twisting. It's always better to use the part to help fixture itself, and it'll just make the outcome stay square and to the measurements you want.
This jib crane of mine here, it has to be hands down probably the best job aid I have in my shop. I just put it in last year. I actually bought it at auction. I think it's pretty old, just judging by the way it's designed and some of the square head bolts on the leveling system. But with that being said, it's phenomenal. I paid $130 for it. To be honest, it was taken apart. I don't think people even really knew what it was or how it would go together, but I've worked with them before, and I jumped at the chance to get that. It makes doing everything so easy. I mean, I don't know what I'd do without it at this point. Like, this frame isn't super heavy. It's probably 150 pounds or so, but the fact that it just saves my back, like, I mean, it's awesome. I love it. I don't think I'm ever going to stop loving it. All right, I got a few pieces cut out here. I'm gonna get this clamped down to the table, get these tacked together. We're giving the back end of this a little bit of a kick on the corners, give some more dimension to the vehicle. I have the front piece cut, and then we'll cut the side rails, start getting it mounted on the chassis itself, and then build.
into place exactly how I wanted it to be, and I can't wait to show you more. I have a lot more content already videoed, so you're going to see the engine in and it's on its wheels here shortly. So hit that like and subscribe. I'm really enjoying what I'm doing here. I hope you're loving it too. I'm trying to get better on my videos, and yeah, let's see where this goes. I got a lot of the other projects in mind. Cheers. I lowered everything down so I could kind of mock up the motor here. So my original plan was to try and use the factory Jetta motor mount, but they're a lot looser than I was expecting. They really let the engine and transmission kind of roll in the car itself, which is not what I want so much for here. This is going to be more or less stationary, and I have bushings that I'll incorporate into my mounts to keep some of that vibration down, but not quite as much play as the factory. All right, we got a couple of the pieces made here. Give you an idea, that's basically how that'll sit. The bushings will get pushed in, and then this will get through bolted. Some flanges that are on here. This is the main front mount of the engine block, so we're going to drill this plate, and then that will meet up with here and fully weld in, and that'll be the front engine mount. So all I really need to do now is we'll get these holes drilled, and we'll finalize our exact position of where everything's going to be. We'll get that welded in. We'll make our brackets, press in our bushings. Front of the engine is mounted. All right, well, we got that all clamped into place and laid out and wire brushed. So I'm going to get some heavy tacks on the corners here, and then we'll flip it over and get welding this thing. I didn't have 12 mil bolts right now, so I just have some aluminum dowel pins I machined down to serve the purpose for now. I've been working on the last couple of days, not really doing any videoing because I was mainly going in and fully welding in the cab now, so everything is fully welded in and we're ready to kind of go on to the next step. Now, we have a couple options. There are several different parts of this vehicle that are independent of each other, so we could work on them at any time. You know, I could continue to work on getting the pumps mounted and all the support brackets for that. However, I haven't decided on the coupling style I'm using yet. I'm still trying to figure that out, sort it out. So that kind of eliminates me working on that side, and the powertrain end of things is going to continue to wait. I do have a bunch of work to do on the motor still, get the new turbo mounted up, get the serpentine system together and fuel lines and everything like that. And then we could be working on the front and putting in the windshield, mounting seats, making doors, things like that, which I'm really excited to do. But what I think I am planning on doing today, or in this video, is working kind of in the back here. We're going to do a little surface grinding, smoothing out these welds on the cab, and then we're going to cut the first piece of sheet metal for the cab, which will be the back of it. I plan on having a nice size window in here, and then directly behind the cab is going to be the diesel fuel tank, and then we're going to have a compartment here that houses the air filter, allows fresh air to come in through a ductway down and into the back of the vehicle, and then beside that will be the radiator and the rad fan, which I plan on having set up to draw maybe 50% air from the fresh air intake where the air filter is. We're going to have a louvered sides with a mesh to keep the snow and water out. But then, like, the other half of the rad fan is going to suck from in the engine bay. And my goal is to kind of create a cooling effect in case this gets really hot, because it's going to be fully closed in. I mean, most engines aren't fully closed in like that. So the rad fan itself, and maybe I need to add another booster fan kind of in an inboard. So we'll figure that out. But my goal here is to have cool, fresh air enter in through a louvered side panel, round for the air filter. We'll probably have the intercooler in there. And then the cool air will travel down this side, in through the back, across the pumps, and the rad fan will be sucking it up and blowing it out across the exhaust. So the rad fan is going to help cool the rad, but also help us circulate air through the engine bay. That's the goal anyways. We'll see if I need to level it up with some extra fans and things like that, which is fine. It's a prototype, right? It's all kind of learning. But yeah, so we'll have that center compartment. That'll be your sort of cool air intake and main fresh air for the vehicle. And then beside that will be the rad blowing outwards. This vehicle isn't really going to go fast enough to have air naturally cool the rad like a car would.
So it's almost always going to be relying on the rad fan to cool it down. And then the exhaust, because the turbo's down in here, is going to pipe up nicely and kind of dump out the side, and the rad will blow air across the exhaust to help keep everything a bit cool. Sorry, I know that was very long-winded, but so the goal of today's video, a good loon there, we're going to work on getting the back cladded in and start seeing what the back frame behind the cab is going to look like. I'm excited, so continue watching.
On the road. so I just went and welded that one in off camera. And we got the first side on, what's gonna become sort of the air intake, air filter, rad air, diverter. So we need to build a about a 2-inch front that'll come up and go about halfway on the rad, and then that'll get closed in. So that fresh air will be on this side, engine air will be on this side, and then the duct will continue going down into that bay, and then the cool air will be drawn down and across all the pumps and motors and then pulled back out by the rad fan. That's the idea anyways. All right, so we're kind of getting into some more intricate design parts here. And I'm going to show you kind of what my intention is. So I have this side bulb seal gasket that I'm probably going to use for my doors as well. But I'm going to put a piece of angle support in here, which is going to work a couple of functions. I'll be able to secure to this for the insert that's going to go here with all those louvers and stuff I was talking about. And it's also going to be the rad support and seal off the air. So I'm just sort of eyeballing that, and it looks like I can weld this in quite nicely, about 3/8 of an inch away. And then I'll be able to put the rad in and push it up against the bulb seal, and then put in the top support, so that rad will be locked right in. So again, that's the idea. Let's see how it goes. A little off there, but perfect. Perfect. Okay, get that clamped. See. Ah, I love clamps. Well, I don't know about you, but that was a pretty good day's work getting this side more or less together, and the shrouds really starting to take shape. Probably wind up calling that enough for this video, and then we'll pick up on this probably next week. This is going to get more of a solid side. This side will have some louvers and some mesh, and the exhaust pipe's going to come out, and maybe we'll even make the insert for here. And you can still get at the rad cap and everything like that, so it's going to work out well. It's all nicely sealed off.
Today I'm going to be working on putting body panels on the machine. I accidentally screwed up and I lost some of the footage of the starting of this work, where I cut out these strips of 100 thou 5052 aluminum and had temporarily clamped them on the machine and through drilled all the holes while it was in place the first time. At this point in the process, I've already gone by and tapped the holes in the machine and drilled out the holes in the body panel to a larger size to allow the screw to go through. So I'm just going to backstep, show you a little bit of that process. I didn't get to start it how I exactly wanted to, but there's a lot of footage to come, and the video is going to show a lot of progress. So keep watching, see how it's done, and we'll have some fun.
I'm really happy with that. That is looking very nice. Gonna be kind of like a Cybertruck Snowcat. Well, I got my new microphone, so that'll be nice. Audio should improve again. I just moved along, did the other side here. It's pretty repetitive. I didn't think you really cared to see all that. I'm gonna start working on the passenger side here, the rear part. There isn't going to be a door here. It's only gonna be a 3-door vehicle. So in order to bring this sheet down, I need a strip to screw into here to kind of keep the same pattern. So I'm gonna add in a small piece of angle here. I'll stitch weld it in, and then this is all gonna be sealed off with sealer when we put the body panels on for a final time. Let's mark that window cutout now. Nice big side window in here. I just found something that I like the radius of, and I'll probably use this for most of the windows. All right, well, I got some of the first pieces I needed marked up and cut out. So I'm gonna put some bends in them, and then I think you'll see what I'm gonna go for here. There we go. There's one of the first sides. That die has a bend in it. Okay, I got a few more pieces cut out, and let's get that same flange bent in them. Works pretty good. Now, I am hoping to be done doing this by hand, because if you've been watching any of the videos,
I have a 4-foot mechanical brake press back there. And I just got the VFD, variable frequency drive. You can see up a box on the top. So hopefully, once I get that thing running and make a couple dies for it, it'll just be a simple push of the pedal at the bottom and comes down and bends the material. Alrighty, I have starting to mock it up upside down just to get some measurements, and then I'm gonna get it over on the table. I'll start tacking up all the corners, make sure it's all square. And then I'll get some flanges on the back side and see what it looks like, I guess. There you go, dimpled. There it is. It doesn't look like much in here, but we're gonna roll it out and you can see what I'm going for. So I have holes drilled in it on the flanges, so I'm just gonna mark those through drill the body panel and into the square tube frame, and then I'm gonna drill out the body panel with a unibit to fit around the head of a riv nut. And then I'm gonna put 4 nut inserts into the frame with a 5/16 stainless bolts. So it's going to be really solid, bolted on there nice and tight. So we'll get these marked. And then set it in place. All right, I've been promising a little bit of a walk around. Here we are. Got a fair bit of the body work on. We got that nice roof overhang. Where am I? Right there. The rad's in, the back cowling. A lot of work to go, but it is looking cool. So if you've been watching the build here, in the last video, I was working on this little roof extension to cover up the cowling there for the intake and rad air and everything like that. So the roof is going to overhang that back end a bit. I don't know, give it a little bit of a flare, make it look kind of good. We matched the angles with the back too, so kind of bringing that tapered back end up top, help tie things together. I want this thing to look really good. So we're going to get to doing some doors, and then after the doors, we'll wrap that and close it all in. I'm going to give you a little bit of a demonstration of how my door is going to work. The full interior of this door opening is going to get a piece of 1 inch by 120 mil angle. The door frame is going to be made out of a piece of 1 1/4, and we're going to set this up at a spacing so that when the door comes shut, it will both clear all of the the body panel screws and compress the weather stripping that we have here, a nice little piece of bulb seal that'll be attached to the door. That'll come in, just put a little compression on it, and then the door latch will hold that. And I just need to make note of the clearances I need on the inside here and to the body panel so that it's not sitting there and going to rattle and make noises. So we're going to do some fabricating, then we'll kind of set all of our angles where they need to be, and hopefully by then my door latches will be in, which will be really nice. I'm happy about the style of door latch I'm using. And, you know, essentially this will be the door that swings open and then swings shut. All right, now I'm going to get this door frame welded up. I'm going to be conscious of where I'm welding first. If I go welding all these inside joints, it's really going to make it change its shape. So I'm going to go and weld these perpendicular miter joints first, which won't have a lot of pull on the way it goes. And then when we go to weld in the insides, the door should stay fairly true. So. All right, let's give you a look. There you go. See, that's why I choose TIG for the things I want to look really good. Well, I got all the holes drilled in here, and I went ahead and actually drilled the hinge side because I laid it out, and it's actually going to work out really nicely to place the hinges in between the those self-sealing machine screws. So I'm not going to screw with the pattern at all. It'll all fit together quite well. So next step is drill the clearance hole through the actual body panel, and then drill and tap the frame and mark and cut out the window. Well, it's starting to look like a door. There we go. All right, so I do have a slight depth change here. The hinges are going to need a bit of a shim behind them to make it flush. For now, I'm just going to use some washers
I'll cut out a nice aluminum shim after. Okay, so I've kind of roughed in where this door latch is going to go. So now I'm going to take the zip cut. We're going to cut that out. These two holes are going to secure onto the actual frame, and then I'm going to add in another piece of angle here. So this door handle will really have, the door handle will be really tied into the door frame, and I think that's going to, give us the best strength. Looks really good. So the handle mounts with 4 holes through the perimeter. So I've got this piece cut up. Now we're just going to have to get this into place. That looks pretty good. I'm happy with that. So now we just have to make the striker that's going to hold the door closed. It's going to get mounted right about there. All right, well, welcome to Inside the Snowcat. We have that striker made. I went ahead and drilled out and put nut inserts in, just as you've seen me do before. And I am going to bolt it on. Moment of truth. Now, I don't have the door jamb in there right now. And as you can tell, the striker likely needs to be spaced in a bit more. But once we have the jamb in there and the weather stripping, I want the weather stripping to seal against the door and not it come right and rattle against the frame. But for all intents and purposes, that is a working door. All right, so that'll be going in there. So we'll be notching that and then cutting that way. I always try to mark out the direction I need to cut, because I've miscut before where you cut it the wrong way, or you cut it on the wrong surface, or you notch out the wrong side. So give yourself some marks. It'll keep your mind on track, and I've just found I have less screw ups that way.
I'm also going to just go ahead and put the second one in while I have it on the table, because I'm going to need the same spacing for this door latch. So every door will have kind of twin pieces like that. Okay, I'd love to take credit that I planned this, but I got completely lucky when I ordered these, and the angle they put on the latch matches like the angle of the door spot on. So, I mean, even the back door that was vertical, it didn't really matter too much, but this is just going to look like it was meant to be. I really do like that. I'm just putting a few screws in here, hold it down, we're going to flip it over, mark out the opening for the window. And then we got to take it off and get that window opening cut out. As with any fabrication, there's always lots of forward and back. I'll be able to put nuts on the inside too if I so choose. I don't think that that's going to hold well enough, so it won't be a big issue. All right, we got that handle in. Now it is time to make a catch. Okay, so we want a 3/4 of an inch space between these bends. Tighten that up just a little more. Well, let's check. Pretty good. Definitely need some shimming, but that is all right. Okay, I just showed Carter how to thread a hole. So, nice and perpendicular. Okay, slow. Let it pull in. Yep. Good. A little more. Good. Okay, now reverse it. Push through the other side. That button. Yeah, push on the other side. Yep, now just slow. Yep. Good. Good. You threaded a hole. Good job. Okay, want me to do all the rest?
Yep.
Okay. Would impact driver have been better? Is that what you're giving me crap when we're not using the right terms?
No.
Yeah, we're videoing though.
Okay, so this lever.
Do you want me to end the video? Do
Part.
you want me to end it?
Yep.
Okay. All right, I'm just going to walk you through what I was talking about outside there quickly. So this is the face that the transmission normally mounts to. The engine is transverse in the car, which means it's, perpendicular to the direction of the car. But anyways, that doesn't matter so much. This is the surface that we need to template. I want to mark out all these bolt holes and the center of the crankshaft so that I can cut a big relief circle to go over the flywheel and clear it. And then we have two dowel points down here and down here. I need to get marked out so when we take it off and put it back on, it's located. It can't move anywhere. And then off of here, we're going to have a bracket that comes out 8 to 10 inches. I really haven't determined how long it needs to be yet. And then that's going to provide the rear mount of the engine to the frame. Right now we have a front engine mount in, but we have nothing supporting the back. I was going to go a slightly different route with this, but I changed my mind. These are coming off and we're doing it a little bit differently. And then inside here, we'll have a shaft that's shouldered and bolted to the flywheel. And then we have a large magnetic clutch, and that's going to allow us to have a neutral position. So the engine can be running, but the hydraulics will not be live. And that's really critical for me because if we're out ice fishing and you got to throw the kids in here and warm them up or something like that, I don't want the machine to be able to drive, so we can kill that. And then it's not hazardous to have kids rolling around in there or anything. And then behind that, there'll be another little shaft and then our tandem piston pump assembly. And that's all going to be supported off of this like bell housing bracket that we're going to make here.
I'm going to go ahead. We don't really need this canvas anymore. As you can see, we laid out all the holes except that one, which I planned on. And let's turn that off. And now we can take this part and extrude it. I want to extrude it. Okay, we're going to select that surface and we're going to extrude it. See, you can extrude it out. I'm just going to enter 0.375, which is our material thickness. And there you go. That is what our bell housing plate is going to look like. And I already went ahead and checked a lot of these circles, centers, and they're close enough. So I'm pretty happy with that.
So what I have here is actually one of the window cutouts from the Snowcat. 60 thou 5052 aluminum. It's not terribly expensive, so I'd rather cut the template, fit it to the machine, make sure I like it, and then I'm going to go ahead and cut the actual 3/8 plate out, just so that I don't waste the money on that 3/8 because I only have enough, I think, for one. But let's go ahead. I'll get this set up and we'll do some cutting. Righty.
is our plate to mount the pump assembly to. There we go. Oh my goodness. Would you believe it? Lines up. Every hole can bolt on. Alrighty. I like it. I like it a lot. Oh yeah, we got that dowel pin in there still. That was messing us up. Alright, well I am happy enough with that let's go ahead, get some of that 3/8 plate on the table. Let's go cut this for real. Okay, well there you have it. That is the engine plate. And then there'll be some angle that comes off here on either side, on all four corners. Then there'll be another plate with a large hole, and then a third plate that shoulders on the pumps. And when it's all aligned, I'll drill dowel it, probably weld this third plate to the second plate. And then the starter, this whole bracket assembly gives me a place to mount the starter in down here where it was originally mounted. And there we go. Wow. That's pretty cool. I really like that.
I got the 4 standoffs cut and prepped. I took the plate off of the engine, and my goal here is to get these laid out on this plate as accurately as I can. So I'm going to need to take some mill scale off this. And then I know that these aren't perfectly the same height, but what I think I'm going to do is stand it off, shim it, and jack it to make it as close as I can. And if there's a slight gap on one leg, that's not going to be a problem, because once I fully weld it in, it'll just weld in. But I think that will be the best way. I could take these standoffs and put them in the milling machine and try and true them off to one another, but I still think I can't skip that step of making sure the second plate and the first plate are parallel, because even welding could warp or move things. So I think I'm just going to leave them the way they are, and I will put little jacks under here and make the plate perfectly parallel, and then come in and weld. And like I say, if one's slightly higher or lower, it won't matter too much. So I know what I want. Like, I know what the end goal should look like here. I'm just not 100% sure on how I get there. So I'm taking things a little bit slower than I would like to, but I'd rather move slowly than have to go backwards through this process. So yeah, unfortunately, I'm really taking my sweet time here, but I think I'm getting a plan together. Sort of building it as I go, which isn't ideal, but there's a lot of factors at play here that I really can't predict from behind the computer. So I really need to lay things out, take my time, measure. Anyways, we'll get back to this.
My goal here is to keep everything as true as I can, and I know this outside is pretty square, being that it was cut on the CNC table, so I'm flushing up with the outside and making sure my line, which is also scribed by a square. But again, like, actual dimensions between these parts aren't nearly as important as parallel. Plate number 2 cut. It looks like it cut really good. Again, this is 3/8 of an inch steel, and I'm not using a very big cutter, but this window is going to allow adjustment of the third plate to align the pump to the center line of the crank. And then it'll get bolted and doweled. But this plate is going to allow us adjustment, which is going to be huge. So there we go. A good amount of dross on that, but again, I'm running a pretty light cutter for the metal I'm cutting, but it's not bad. I mean, dross is one of those things, right? It's nice to get rid of, but if it comes off easy, like, oh, that was that bad start. But I'm pretty happy with that. I mean, that's really nice. Like I say, there's dross on there, but when it just comes off, who cares? It took a few attempts. I was adjusting the THC voltage, which is the torch height control, because I've noticed sometimes when it's cutting this thicker plate, I'm left with a bit of a taper. When you're getting a taper on both sides, your torch isn't low enough. So torch height control is trying to automatically adjust the torch height, but it was using a smart voltage setting. So it was picking a voltage that it was trying to follow, but that voltage was too high, which means it was too far away. So I was bringing that down and getting like really nice cuts, like bang on square. The dross didn't clean up too badly. There was a little more, but quite happy. So this is the plate. Let me show you here. This is the plate that the pump will actually be mounted to. And then there'll be a support bracket off the bottom to support the mid body of the pump as well. And then all of that is going to be on there with jack bolts to help locate it to center. Probably being maybe a little picky with centering this thing, but you got to have full adjustability because I've introduced so much error in everything I've done. I've tried to be as precise as I can, but when you're talking pump alignment, I mean, you're talking thousandths of an inch, not eighths of an inch or 16ths, right? 60 thou is a lot different than 2 thou. So that's okay. By having 2 jack bolts here and 1 top, 1 bottom, we'll be able to locate those pumps in perfectly. But next step is to go ahead and put the homemade boring bar I used for the wheel motor mounts, actually, put it back in the lathe there, or put it back in the milling machine, find rough center on this. And again, rough center will be good enough because we haven't lined anything yet. And then we're going to bore it out to shoulder on here. All right, I'll get that set up. I am happy with that. Well, with my amateur machining skills, I think I got something that I want. So the next step here is to make some plates for our jacking bolts. 1 top and bottom and 2 side to side. That should allow it to stay square but move up and down, back and forth. I need to mark these holes for the pump mount.
and then go ahead and mark some actual through bolt holes on this as well. So I'll continue doing that, I guess, but I'm going to clean up a little first. It's pretty messy. Well, that looks like exactly what I'm looking for. Mostly. So, take this pump plate, which, to my surprise, with this plate cooling down overnight, it shrunk down that little bit I needed, and now that's the kind of fit I got. Awesome. Woo! Game changer. Oh, what did I ever do without that? All right, so I love having a crane. That is a nice sight to see. Now, if you think I have a long ways to go, you're completely right. But I am happy with that. Oh, well, we're getting there. So first things before we get to start welding stuff on, I'm gonna have to go ahead, smooth down a lot of these welds from when we built the chassis. So I'm gonna do the bottom first, we'll get those smoothed out. I'm gonna get the pieces ready to get bent for all the chamfers on the front and the rear. And we're gonna clamp it in and start welding. So, to start, I guess my favorite thing, let's do some grinding. I'm gonna take my time with this. This isn't a cheap piece of aluminum. I really don't want to screw it up. All right, well, this bend is pretty good. I mean, it really takes nothing to bring that back in, and even this, you know, I can clamp it in with my hands pretty easily, so I'm pretty happy with that. There's not really much complaining there. The big thing is that the bends pretty much line up where they need to, so. All right, well, the front end's looking really good. Now, I figured I was going to have to cut this down to one of the axles to make a joint along it, and I didn't even check this ahead of time. I just figured it was going to be long. I'll cut it down to where I need. But, well, let me grab the camera and show you this. I mean, there's getting lucky and there's getting lucky. It's not quite centered on the axle, but that doesn't matter because I can lay a nice seam in there, bring the other one in, another nice seam in there, and then this back part can wrap around. So that's looking really good. Okay, well, I got the round of passes done there, and I'm really happy with how that's welding in. I don't think you can ask for too much more than that. You know, it is a spool gun, it's not TIG, but that is going to be watertight, so I'm very happy with that. Okay, getting some nice long passes in. Like I say, I've done one lap around, so I'm going to let my gun cool down a little bit. I don't feel like burning that up, and then I'm just going to keep making passes around. Okay, I'll give you a little bit closer look here. We got that front end done. I have it notched out for all the axle holes. Okay, that felt very painful. Drill holes in it, but we'll weld it up. Boom, there we go. I just went ahead and tigged that all into place. That is fully seam welded. There you have it. One side is officially done. Went ahead, tigged all that in, as I mentioned. Wheel motor is going to sit in here. That'll drive the drive tire or the sprocket. Haven't yet determined, but it's really starting to look like something now. And if you've made it this far through the video, all the way to the end, I really appreciate you watching. Thanks for all the support, everyone. Again, if you're liking this build, share it around. I think this is going to be a pretty interesting vehicle when it's all said and done. So thanks again, and we'll see you in the next one.